Hello and welcome today to a video where you will learn to drive your own brushless motors, your own high-speed 30 volt DC motor using the RX23T kit. First, you will understand how to configure the kit. You will see that this is a very flexible inverter which is able to drive up to 48 volt DC motor. You will learn and see how to use the auto-tuning process by using a simple PC GUI without using any oscilloscope, but still having access to many software resources. And finally, how to tune the algorithm and tune the parameter to reach the highest speed you wish for your motor. You will see that the results we reach are very nice for both no load conditions and with load conditions. But let's have a look about the motor we will use today. And this is a three-phase motor without any encoder and all sensors, permanent magnet using a neodymium magnet. The nominal voltage is 30 volt DC. The no load speed is 43,000 RPM. The nominal speed is 40,000 RPM. Maximum power is 100 watt. No load current is 200 milliampere, but the max current is 3.5 ampere peak, with high load conditions. Which step will we follow? The first one, we'll prepare together the materials. We will set up the software running on the RX23T. We will set up the jumper of the kit and connect everything. And finally run both the auto calibration for the coefficients of the current PI and the process to identify automatically the three parameters of the motor. First, let's prepare the material. You need the 23T kit, of course, the E1 debugger. In terms of software, you need the eSquare Studio, you need the motor control demo PC GUI installed of your PC, also the Y-rotated RX23T embedded software. These types of software could be found on renesas.eu/motor control. The motor, of course, and finally a power supply of 30 volt, which can deliver up to 2 to 3 ampere. Let's move on to the final steps, which is basically preparing the embedded software running on the RX23T. Before doing this, the first thing is to supply the power to the kit via the USB, to plug the E1 debugger to the board, launch the eSquare Studio and import the complete RX23T project source code. We will disable the flux weakening in order to achieve the maximum speed at the maximum current we want. We will build the project, of course, launch the debugger and load the program into the flash of the MCU thanks to the E1. The first step is basically to connect the power supply to the board using the USB cable. So the board is basically powered with the USB. And after that, to connect the E1 debugger directly onto the board and check the status of the LED. After that, you basically need to launch the eSquare Studio. We will import the software into eSquare Studio. I just stored it on the desktop. And I would like to ask you to open the source folder and open the customers.h file. In the file, if you go to the bottom, I'd like to ask you to disable the flux weakening. It's a line 167, in order to ensure we can reach the maximum speed of the motor. After that, you can build the project. And finally, you can run the debugger program the software into the flash of the microcontroller. During this, you can check the status of the LED on the E1 debugger. When it's finished, you can remove the E1 debugger easily. Finally, we just need to set up the jumper of the kit, which is pretty simple on this example because we will move the GP1 and GP2 to the position 1 to 3 in order to enable the use of external power supply, the 30 volt DC, and to ensure that the USB communication is fully isolated. The other jumper, GP10 to GP16s, remain unchanged as they are by default set in order to use the onboard MOSFET's power stage. Finally, the last 3 steps to follow are first to run the intuitive PC GUI and enter the known parameters of the system and of the motor. Second, to launch the automatic current PI tuning to find KP, KI and launch the motor identification to find the motor resistance, the inductance, and of course the flux permanent magnet. And finally, to do some tests at different speeds and adapt the speed PI coefficients if it's needed. Launch the PC GUI, connect the RX23T board, and the first thing we will do is we will launch the parameter settings and start from a very clean setup. We will enter 33 in the first line, right, click right, and reset the hardware board. We can close and open again, and normally we will start with the default one. The next step is to enter the parameter we know of the motor and of the application. So the minimum speed in this case is 3000 RPM, maximum speed will be 30,000 RPM. The acceleration and deceleration ramps will be 5000 RPM per second, 1 polar couple. We will set up the startup current at 600 milliampere and the maximum current to 2 ampere in this case. The 5 parameters that we will find automatically are set to 0, and we can check in the bottom at which frequency we work. In this case it's 8 kHz control loop and 16 kHz PWM. Let's run the PI automatic tuning to find KP and KI automatically. So we found quite low value, 7 and 51, and the idea is basically to check if we can get better value by increasing the maximum current. I set it up to 3 ampere, and I run again the KP-KI auto tuning, so 7 and 51. The new values that we get is 7 and 47. It's just showing us that maybe the parameters are a bit high and that we need to reduce them. So I test with some low step here. We can see that there is really a high frequency. So KE must be reduced and KP also is much too high. So I'm trying here several values, and we can find some acceptable value in close to 3 to 4. It's an iterative process in this case, as you can see. tested 3 and 10 and trying to increase the current. And finally the 3 for Kp and 7 for Ki are a good compromise. Now let's run the motor identification process where we will find automatically the stator resistance, the synchronous inductance and the flux permanent magnet. Normally the motor is starting to run a little bit. It's a good sign. So we found a value of 1.2 ohms and 0 Weber. Can do it again to check. We will start by giving 1.5 times the minimum speed, something like 4,500 RPM. So it looks okay. We are running at 31 volts. And step by step, we will try to increase the speed. We also need to check that everything is working fine. When we increase the speed again. By looking at the phase, we can see a lot of instability, so we could play with a couple of parameters, and we will select the flux feedback gain, which is supposed to ensure a higher stability. It's the gain which is used by the flux estimator. So by increasing the value for the high-speed motor, we can increase the stability. It looks a little bit better, so let's carry on increasing the speed and check how the motor is reacting. We'll give some steps until 10,000 RPM, and the idea is to reach higher speed. These motors are made to reach high speed, so more than 10,000 RPM, 20,000 RPM, and so on. By checking the phase and the current, we can see still some instability depending on the speed at the end of the day. The current is increasing a lot at the moment. Yeah. And finally, when we reach the 30,000 RPM, we are below 1 ampere. And the phase is very stable, and the current also. Let's recap. Simply by using the RX23T kit plus the E1 debugger, the E2 Studio and the PC GUI, you can run your low voltage and high speed motor. Within only 15 minutes, you can reach up to 30,000 RPM with load and without any load. So just to conclude, the auto-tuning system and process running on the RX23T allow you to drive any types of three-phase permanent magnet motor. So feel free to get your own kit on the RenesasShops.com and download the complete material of the kit on the renesas.eu/motor control. Thank you very much. Bye bye.